with the intention of making the young cost engineers and quantity surveyors the future stars in the world of construction. That is, we have organized a series of webinars on futuristic topics to disseminate knowledge. And this is the third such seminar we have organized, and we intend organizing monthly webinars in future as well, and we will keep you informed. So before we start our formal presentations and the formalities, just a small housekeeping note or a couple of notes. We will be having a Q&A session at the end of the presentation. So if you have any questions regarding today's topic, kindly send a private message to me. Again, my name is Dulisha. Or alternatively, you can post it on the comment chat box as well, and then I will make it at the end. I will post it at the end. And also, one final thought, kindly keep your mics muted at all times. So modular construction is gathering pace all around the world as of late. And out of several techniques available for modular construction, PPVC, or prefabricated, prefinished volumetric construction, which is also known as MIC, or modular integrated construction in Hong Kong and other countries, has come to the forefront as a revolutionary innovation. And I predict this could be a game changer for future construction. And to tell you more about it and how valuable it is, we have two eminent promising professionals here with us today. Let me introduce two of them. Our first speaker today is none other than Surveyor Sunny Wong. Surveyor Wong is a quantity surveyor practicing in Hong Kong. He is the vice chairman of the Young Quantity Surveyors Group and a council member of the QS division in Hong Kong Institute of Quantity Surveyors. He has a wide range of experience in public sector buildings. And our second speaker today is Jacqueline Huang. She is a contract officer practicing in Singapore. Jacqueline is a council member of the QS division in the Singapore Institute of Surveyors and Valuers, and the chairperson of the Social and Engagement Group of SISV. She has a wide range of experience in residential, retail, and industrial sectors, both in public sector and private sector. And currently she is working in aviation industry involved in infrastructure work. So ladies and gentlemen, without further ado, may I now invite Surveyor Wong to start the presentation, followed by Jacqueline. Over to you, Wong.
Okay, so I guess everyone can hear me that, right? Okay, so today our topic is about the modular construction, or you can say MIC or PPVC in Hong Kong and Singapore. We will introduce what is MIC and what is PPVC later. So today our content is, we'll share our speaker's profile as Alicia just shared, and we will talk about what is modular construction, those definitions, and we will talk about how it goes in Hong Kong and Singapore respectively. And at the end, we will have a comparison and summary. Okay, so actually just for a few seconds to remind you all about our outlook. Yep, which this is covered. Okay, so what is modular construction? Modular construction, we have two terms here. One is MIC and one is PPVC. MIC stands for Modular Integrated Construction, while PPVC stands for Prefabricated, Prefinished Volumetric Construction. Both MIC and PPVC are same in the context, which is one of the innovative construction method now by adopting the concept of factory assembly followed by on-site installation. Integrated freestanding volumetric modules with completed internal finishes, building surfaces, works, and furnitures and fittings are manufactured in a controlled area of site, which is the factory, and delivered to site for installation in a lab-like manner. MIC also claims to enhance product quality, at the same time improving construction productivity and safety. And MIC has been implemented across the world many countries have already implemented MIC or PPVC for construction of housing, hostels, and other facilities, which seems to be successful in terms of productivity and cost. So what is the difference between MIC or PPVC with the precast components we normally come across? MIC or PPVC is an innovative construction method. By using them, the building is substantially completed off-site, which you can see the figure on the left-hand side is the MIC illustration. This can reduce the on-site construction process and enhance site safety, hence achieving higher productivity. Freestanding integrated models will be completed and delivered to site for manufacturing. There are mainly three types of MIC or PPVC models. First one is reinforced concrete model, steel frame models, and hybrid models, which is a mix between them. On the other hand, prefabricated components only comprise of small parts of a building. Structural parts other than prefabricated components need to be built using conventional in-situ construction methods. Substantial amount of formwork, steel fixing, concrete works, etc. are involved. Interior decoration and laying of pipes, etc. could be only carried out thereafter. Common prefabrication components including prefabricated facade, prefabricated slab, prefabricated wall, prefabricated staircase, semi-prefabricated slabs, and bathrooms. So just now we have mentioned about we have a reinforced concrete model and steel model. We will talk about the difference of these two types of PPVC or MIC models here. For reinforced model, usually it would be heavier than the steel model. Wall and floors are manufactured with reinforced concrete, and the maintenance is similar with the conventional construction. On the other hand, for steel modules, it would be lighter. Walls are usually manufactured with steel frame with lightweight walls, while flooring can be concrete or lightweight flooring. Although the steel model is relatively lighter, supplemental maintenance manual for the modules are required. So, what is the advantage of the MIC or PPVC? Mainly, we have four here. Improving the productivity, which means prefabrication of the models can proceed concurrently in the factory, while other site works are ongoing, streamline the construction process. The on-site construction activities can be also significantly reduced through adoption of MIC or PPVC. It can potentially achieve a productivity improvement of more than 40% in terms of manpower on site and more than 20% of time saving. The second one is the reduction of on-site labor. The number of labor working on site can be significantly reduced. These laborers are relocated to work in the factories with a better work environment. In addition, more construction off-site leads to less time on site and fewer individual man-hours working at height. By reducing the construction and installation activities and manpower from the site, placing them off-site and in a controlled factory environment, fewer workers will be working on site and leads to a fewer accidents and less downtime. The third one is a better construction environment. As most of the activities are completed off-site, a reduction of environmental pollution can be ensured as the dust and noise pollution are potentially minimized. Besides, dismantling to these surroundings neighborhoods during construction can be diminished. The fourth one is the better quality control. MIC or PPVC deliver the majority of the final product from the control factory environment, leading to increased reliability with higher quality finishing. Sequence of work can be planned more efficiently with better logistic coordination. So we will talk about how is the modular construction MIC happening in Hong Kong. First, we'll talk about why in Hong Kong we have MIC. The reason for having the MIC in Hong Kong is to mitigate the long-term housing need. In 2007, there is a Hong Kong 2030 Planning Vision and Strategy by the Hong Kong government. However, there is still a massive gap between the supply and demand of the housing in Hong Kong, and the property price did not go down as well. Bringing down the construction cost might be one of the way to release the pressure of high property price. The Development Bureau in Hong Kong has implemented Construction 2.0 in 2018 to ease the increasing pressure of the public sanitary as the result of the higher cost, declining the productivity level and a series of incident records. So the Construction 2.0 in 2018 aimed at tackling the challenges for significant future construction volumes, high cost, unsatisfactory mega project performance, and unsatisfactory site safety performance. The Building Information Modeling and Modular Integrated Construction in Hong Kong has been proposed to boost the predicted construction volume significantly in the next 10 years from 2020, at the same time lowering the construction cost. So here's the history of MIC or prefabricated components in Hong Kong. Back to the 1960s, the Hong Kong Housing Authority has implemented the precast concrete components, including precast facade, precast staircase, and semi-precast slab. In 1990s, the average precast concrete volume is about 18% in the construction industry. Later on in 2008, the Housing Authority also implemented the precast volumetric bathroom and precast volumetric kitchen in the public housing project. This we call it VPB and VBK are similar to concept with the MIC, which the whole bathroom was prefabricated prior to installation. In 2017, the feasibility studies of MIC has been started, and different government bodies have already issued guidelines and pre-acceptance mechanism. As mentioned earlier, the Construction 2.0 in 2018 has proposed some pilot projects for implementing MIC. Some of them are listed here. The first one is the student residence in Wong Chuk Hang for the University of Hong Kong, which we will have a case study later. The second one is the Discipline Service Quarter for the Fire Services Department. And the next one is the inner cell for the Hong Kong Science Park. So we'll talk about the MIC in Hong Kong, how the acceptance guideline here. Actually, we have a construction industry council in Hong Kong helping the practitioners to get with the latest environment of the government. The Construction Industry Council has issued some guidelines of the statutory requirements for modular integrated construction in September 2019, which cover the requirement and the guidelines from the government departments stated here, including the Buildings Department, Facility Department, etc. The guideline also include the construction industry issue to help the practitioners with the government approval. Okay, so now we will share two case studies in Hong Kong. The first one is the student residence for the University of Hong Kong. It is as mentioned before, this is a student residence and it would be anticipated to complete in Q4 of 2023. This is a 70-story twin tower with podium. The podium was built with conventional construction. A total of about 1,200 hostel places will be provided in about 850 modules. The modules will be constructed in the 6-side steel modules weight, and each module will weigh about 6.5 to 14 tons. So about the configuration of this Hong Kong U student residence, from the very beginning, actually the approved plan is as the left-hand side. It would be constructed in the conventional method. After the Construction 2.0 in 2018, the University of Hong Kong actually modularized those rooms into the standard type and revised toilet layout to suit the MIC unit. The revised plan for MIC module is like the right-hand side. You can see those components are fit for the MIC construction. The second case study is about the quarantine camp Tyranny. The quarantine camp is one of the quarantine camps adopting MIC in Hong Kong that was built by renovating existing holiday village for the quarantine camp. The camp consists of two sites. Site A was originally a basketball court, which consists of 118 modules, and it only used 25 calendar days for the completion. Site B was originally a football field, which consists of 34 modules. So about the quarantine camp, here is some picture about the quarantine camp, the interior design, including the bed, the bathroom, and the floor plans. So MIC in Hong Kong challenges. Since MIC is still at the pilot stage in Hong Kong and not many data could be analyzed and obtained, the successfulness in terms of the implementation of MIC here is not based on the finalized figure of the MIC projects. According to the research that I'm currently conducting, the construction cost of MIC can be reduced by 10% when compared to the traditional in situ method. It is expected that the magnitude will be increased after a learning process of the Hong Kong construction industry. However, since most of the construction projects in Hong Kong are still adopting the traditional contract conditions, a fast-track MIC project may lead to a poor cash flow concern to the contractor. A large amount of money is required to be invested by the contractor before the contract starts. And currently, payment system was based on the actual work done completed on site. As a result, majority of the payment will be paid near the completion of the project, creating hard time in the cash flow for some contractors during the construction. So how is the QS or cost engineer's role in Hong Kong for MIC? QS duties, such as those quantity takeoff, is actually similar to the conventional method, except the components shall be measured by module by multiplying the number of modules to avoid missing any one of the double step or double wall. The real impact to the QS or CE is whether an appropriate contract condition shall be constructed to ready for the MIC contracts to share the risk between the employer and the contractor. The current condition may shift the risk and burden more to the contractor. Whether some new conditions or special conditions to be implemented in the future of MIC project is crucial. And then we'll talk about the MIC and PVBC happening in Singapore.
Okay, thanks, Annie. So thanks, Dulisa, for the introduction in the beginning. So once again, good evening all. I'm Jacqueline from SISV, Singapore. So very happy and warm welcome for everyone to join our section tonight. So I hope that all of you will have some takeaway after our section today, and feel free to interact with us through the Q&A section later, or even through the LinkedIn or emails connection later. So as mentioned, the modular construction in Singapore is actually named as PBVC, which is the prefabricated, prefinished, volumetric constructions. So similar to Hong Kong, why Singapore want to have the modular constructions? It's also because it's an initiative by the Singapore government. So the Singapore government would like to raise the Singapore construction productivity level. So back then in year 2015, the government introduced the second construction productivity roadmaps, which to set aside a fund, which is amount to 450 millions to raise the construction productivity through DFMA. So what is DFMA? So actually there's a lot of short form that being used in Singapore construction industry. So please bear with me for some term explanation actually along the way. So DFMA actually stands for design, for manufacturing and assembly. So there's a lot of products due to the DFMA efforts. So PVBC actually is one of that. other actually include, as you can see from the slide, the MET, which is the mass engineered timber, and also the prefab MEP system, the mechanical, electrical, and the plumbing system. So ever since the productivity roadmap being implemented, the Singapore government has actually successfully generated more than 35 PBVC projects. So the slide that you all are seeing now is some of the key PBVC projects in Singapore so far. So similarly, I actually will also further introduce 3 of them as the case study at the later parts. And actually before the current COVID-19 pandemic, right, the Singapore government has actually targeted to create 39 more PVVC projects in this year and next year. So currently, I'm not sure how this target actually being affected. But as the construction industry in Singapore is still quite uncertain due to the current pandemic, the target number will surely receiving some changes. So currently, beside the funding that I shared just now, another way that the government helped to generate the PVVC demands is actually making the adoptions of the PVVC as a mandated requirement to selected non-landed residential and hotel project under the government land sales exercise. So it means that if the developer would like to buy the land to build condominiums or hotel from the government, they actually will buy the land with the condition that they will using the PVVC method to build the condo or the hotel. So similar to Hong Kong, currently we also have 3 types of PVVC system in Singapore, which is the concrete, steel, and also the hybrid. The PVC construction process in Singapore is split into 3 phases, as you can see from the photo. The structural carcass factory at the overseas, the architectural fit-out factory in Singapore, and the on-site installation. So this is the graphical explanation of the PVC construction process in Singapore. The green dot at the left, you can see, is the structural carcass factory that is located in Malaysia. Then the orange dot, the 2 dots here, is actually the archi fit-out factory in Singapore. And the purple dot is some of the example of the construction site around the Singapore. So you may be wonder that why the offsite factory, the structure and the carcass need to split into 2 types. Why can these 2 factories actually combine in the same factory as what Hong Kong and other countries did? So I would say this is the unique part of the PVC development of Singapore along the way. So due to the land scarcity of Singapore, it's actually very difficult to find a big land to just build a huge offsite PVC carcass yard in Singapore. So almost all the PVC structural carcass factory are actually built in Johor, Malaysia, as they actually have more big and vacant land. And due to the high quality control and check of the archi fit-out of Singapore Authority, it actually require highly skilled worker to carry out the archi fit-out works. But however, the pay scale between Malaysia and Singapore is actually in 1:3 ratio. So it means that the same highly skilled worker, if let's say they work in Malaysia, for example, if let's say they receive 1,000 ringgit as a salary, in Singapore, they also will receive 1,000 Sing dollar, but it's 3,000 ringgit as convert back to the ringgit. So that's why actually many skilled workers choose to work in Singapore. And the PVC contractor is actually having a hard time to find sufficient skilled worker that can meet the Singapore architectural quality requirement in the Malaysia factory. So that's why the fit-out factory need to be built in the Singapore instead. So next, I will actually share about the module design constraints. So first is the transportations. So the logistic for the modules transportation from factory to site will actually determine whether the size and the volume of each module design. So the size of the single module actually will be limited by the dimension allowed to be transported on the public roads. And the height consideration also need to be factored in if the transportation will passing through the overhead bridges. So actually this in fact will affecting the number of modules to complete to configure the unit layout design. So as you can see from the table here, the height, the width, and the weight restriction on the dimension is listed here. So let's say the module transportation, the module size actually exceeding this controlling parameter, the authority permit and the police escort are actually required. And all of these additional requirements are actually additional cost to the overall contract sum, and which I will further actually touch on the cost part at the later part of my presentation. So the second module design constraints is actually hoisting machine. So here are some of the crane examples that are currently being used to lift out the PVVC at Singapore construction site. The lifting weight of the PVC module is the key consideration to decide the type of the crane, and the choice of the hoisting crane will also affect the construction costs. So therefore, with the design constraint in mind that we just learned, the architect and engineer actually need to think thoroughly on how to configure the PVC module of a unit so that it can still meet the authority requirement. The PVC module is buildable, which means it's able to deliver from point to point and also able to lift out when actually reach the site to fit in the building, and without compromise the quality, and also will not incur unnecessary cost premiums. So here are two examples of the PVC module configurations. The example on the left is the perfect split out of a 2-bedroom unit into the 4 modules. As you can see, the module A actually is they cut into living room and the dining room. Module B is a bedroom and bathroom. Module C is the master bed and bath, and module D is kitchen. But however, the second example on the right, you can see the yellow part is actually too big, so that it's actually unable to fulfill the transportation and the hosting constraint that we had learned in the previous slide. So for this case, the living, dining room, and kitchen will not be able to translate into PVVC module, and this portion will be doing conventional construction method instead. So this slide is just to show the 3D model of the 2-bedroom PVC module that we see in the plan previously. So the module A to D. So further to the yellow area that we actually learned that is too big to translate into a PVC module. So some of the common area of the residential or hotel block are also unable to be able to translate into the PVC module. So for example, on this block plan, the common corridor, the staircase core, and the lift core will not be configured into PVC module, and so that's why they also will be built in the conventional construction method on site. So after understanding the design constraints on the PVC configuration, I believe now all of us will be able to appreciate more how this first authority guideline is coming from. So BCA actually stand for Building and Construction Authority of Singapore. It's the authority that governs the rule and regulations of Singapore construction industry. So no doubt BCA actually said that the adoption of PVC as the mandated land sales requirement for the selected residential and hotel development. They also understand that certain part of the construction is unable to be PVC module, and therefore the minimum requirement of the PVC adoption of a PVC project is actually set as 65%. And there is also the minimum archi fit out to be complete on offsite as set as this table below. So which means some of the archi fit out, right, is allowed to do on site. For example, the floor finishes, the 80%. The remaining 20% can be the floor finishes between the two, linking the two PVC module, which is unable to do in the factory. And some of the example also like M&E equipment, lighting, and some loose furniture items, which are tend to be damaged during the process of delivery, are also allowed to be installed on site. So beside, there is also a PVC acceptance framework as similar to the Hong Kong or the authority acceptance frameworks that the design team and the construction team will need to apply and obtain approval before the start of the PVC constructions. So this framework consists of 2 parts. The first one is the PVC design and construction method must be accepted by the Building Innovation Panel, the BIP. And second is the PVC contractor must be accredited under the PVC Manufacturer Accreditation Scheme. So to date, there are 16 number of the archi firm, 17 number of the CNS firm, and 25 number of the contractor have PVC project in their portfolio. And there are also 28 numbers of the PVVC manufacturer being accredited for concrete PVVC system, where 15 number is qualified for the steel PVVC system. So next, I will be sharing the 3 PVVC case study in Singapore. So first one is the Nanyang Technology University North Hill Hostel. So completed in year 2015, the NTU North Hill Hostel is Singapore's first public PVC buildings. It is a student hostel, 8 blocks, 13 story, with close to 1,600 room. So it used out 1,200 number of the steel PVC modules. As this is the first PVC pilot project in Singapore, you can see that the cost premium of the PVC adoption is quite high, which is close to 18% more as compared to the conventional construction methods. So the second case study is Crowne Plaza Hotel Extension. So located just next to the Changi Airport and completed in year 2016. Crowne Plaza Hotel Extension is Singapore's first private PVC building. It is a hotel building, single block, 10 story, and 243 rooms. So it is a hybrid PVC module, which means it's using the steel frame but concrete for blaze. And it's only used 26 days to finish the installation of the 252 modules. So one interesting fact about this case study, right, is actually this building is sort of being featured as a Singapore key PVC development, and therefore the time-lapse video on the PVC installation process actually can be found on YouTube. So for those who are interested to find out more, you actually can search and view it from YouTube by yourself. So, and also as the builder is getting more familiar with the PVC construction process, you can see the cost premium for this project is actually lower down from the previous 18% to a range of the 10 to 15%. So the last case study is Clement Canopy. So just completed last year, the Clement Canopy is so far the world's tallest concrete PVC building, which is about 40-story high. But however, just in Singapore itself, there's another 56-story high PVC residential building is under construction. So in fact, his world tallest position actually will be substituted by that building anytime soon. So, okay, this is a condominium project, 505 units with 1,866 PVC module. It's using concrete PVC system. So I think just now the 3 case study that I shared about, right, is using the 3 different type of the PVC system. So now come to the key part of my presentation today. So what is our role as a quantity surveyor or cost engineering in the PVC development in Singapore? So how does this game-changing technology has affected the QS or CE in Singapore so far? So first, let us talk about the cost implications. So based on the latest market study, so with more PVC player in the market, the estimated cost premium of PVC has been dropped from the beginning 18% to currently 8% as of last year. So there are actually 6 cost drivers. So the first one, the precast mold. So unlike the precast component, one formwork maybe can be used for different parts or side of the components. The precast mold for each PVC module is actually needed to be custom made. Okay, so you can see the example of this 3D model that we see just now. Module A to D, they are actually totally different PVC module as compared to each other. So that's why the custom, we actually need 4 precast mold for each. Okay, then second is the transportations. So as mentioned just now, the extra cost will incur if the authority permit, which is LTA, the Land Transport Authority, and police escort is required for the transportation of the PVC module from point to point, be it from offsite factory, Malaysia to Singapore, or from Singapore factory to the construction site. So the cost for the permit and the police escort, right, actually is counted on per trip basis. So the third cost driver actually is the hoisting crane, as we have shared just now. Then the fourth one actually is to build the unusual, the large, the offsite yard. Then the fifth one is the application of the additional temporary occupation license, the TOL land, for the temporary storage of the PVC module before the on-site installations. And lastly, we'll also incur additional supervisions for the off-site or factory. So next, I will share about the contractual implication. So the procurement methods. So due to the module complexity, and most of the PVC will have own proprietary system, it's actually highly encouraged to engage the PVC contractor early during the design stage to facilitate the integrations of the design and the construction process. And it also will help to provide a better and more effective technical solutions. And beside the traditional design build procurement method, design and build procurement method is actually more encouraged for the PVC project. So the payment arrangement. So in Singapore, payment for material offsite is not typically practiced, and contractors are usually paid as work are completed on site progressively. But as you can see now, the almost all PVC module actually is completed offsite and then transport to site for the installations. If the owner still following the traditional way of only paying the PVC when it's fully completed, delivered, and installed on site, it will definitely affect the contractor cash flow. Therefore, along the way, the two-payment approach in addressing the PVC payment issue has been established in Singapore. So for public sector, with the provision of the advance payment bond, the advance payment of 20% of the total PVC cost, which is subject to the maximum 10% of the total construction sum, actually can be paid to the contractor upfront. So for private sector, beside the similar advance payment approach, similarly with the provision of the advance payment bond, another milestone payment on the agreed percentage on the milestone is also being developed to facilitate the PVC payment issue. So this is the example of the advance payment clause actually being spelled out in the public sector project. So the option module D inside the public sector conditional contract, the PSSCOC. Then this is the example of the milestone payment. So the percentage that you're seeing in the slide just now, right, is actually is the most common schedule for the milestone payment in currently in the Singapore private residential project. So the 30% of the completed structural carcass can be paid upon this carcass being delivered to the Archi fit-out yard in Singapore, and another 30% of the completed Archi fit-out PVC module upon delivered to site, and the last 40% for the PVC module upon successfully installation to the buildings. So next is the insurance. So due to some of the off-site work is being carried out in the overseas factory, so on top of the existing construction insurance coverage, there are two particular areas of the insurance actually need to be addressed to. So for the first one is the additional property all risk policy. Is required to cover the off-site factory in another country. So for this example is Malaysia. Then second is also to ensure a proper marine cargo insurance is being take place. It's required to cover the shipment or transit of the PVC module from another country to Singapore. And both insurance policy are actually need to be insured in the joint name of both the contractor and the employer. So for PVC project, it's also more preferred for the employer to procure the insurance by themselves or the contractor to procure the insurance from the employer insurance broker. So instead of just the contractor to buy the insurance by themselves. So the reason behind is if the contractor is to procure the whole construction work insurance by themselves, they may miss out these two additional overseas coverage, which is important for PVC project. So lastly is the nominated subcontractor, the NSC arrangements. So as some of the NSC product delivery or the construction work are also being affected by the PVC arrangements, so back-to-back provision relating to the payment, the advance payment bond, and the insurance shall also be provided in the NSC contracts. So as a QS, we shall also ensure that the NSC contract sum include all the delivery, be it to the offsite factory in other country and also in Singapore. So now I will just conclude with a comparison and summary between the MIC in Hong Kong and PVVC in Singapore prepared by me and Sunny. So as you can see, why Hong Kong and Singapore want to introduce the MIC and PVVC is the reason actually is the same. Is actually wanted to improve the construction productivity and also wanted to improve the construction site condition to become safer, cleaner, and more conducive for the worker to work. And in terms of the year implementation, Singapore is slightly earlier, is in 2015. Hong Kong is in 2018. The main driver for both actually is a government initiative. And so far, the number of completed and ongoing projects for Hong Kong is 15 plus, and in Singapore is more than 35. And actually, both Hong Kong and Singapore also have their own authority acceptance frameworks. So the type of PVVC and the MIC is the same, the three types. And the module configuration, in fact, this is something quite amused me when actually I discussed with Sunny in our discussion. So in Singapore, for as you can see just now, I show you the module configuration. One unit actually can split into 4 to 5 modules, but in Hong Kong, one module actually can fit to 2 units. So it's something quite different. And for contractor procurement, in Singapore, it's more encouraged to use design and build, but Hong Kong is still using the conventional way. And for both countries, we also agreed that we'll engage the PVC or MIC consultant early. But in terms of the ECI, the early contractor involvement, so far, there is not a common practice in Hong Kong, but it's quite common in Singapore. And with regard to the estimated cost premium, for both countries, it's quite similar, like 9% to 10%. And the estimated time saving, as there is no completed project in Hong Kong so far, so there is no data that we can draw for. But for Singapore, is according to the study, the time saving is around 17 to 20%, which is around 2 to 6 months. So in terms of the contractual arrangement, for Hong Kong, as you can see, for payment and the insurance coverage is still similar to the conventional construction. But in Singapore, they actually looking at the advance payment approach and the milestone payment approach for the payment for the material offsite. And they also have extend the coverage to the insurance coverage to the overseas yacht and the shipment. But no doubt Hong Kong, the payment arrangement is still similar to the convention. They also implement the advance payment, they also require the advance payment bond when they actually pay for the advance for the MIC. Okay, so as you can see from the table just now, Singapore actually have more PVC projects so far as compared to Hong Kong. So that's why actually last year, the HKIS QS division, they actually have conducted a study trip to Singapore. So as a very long, close regional relationship between the two institutions, the SISV QS division has hosted the HKIS QS division for the 3-day trips. As you can see from the top left, the photo, the SISV, we actually hosted the HKIS in our SISV office. And the bottom left, we actually brought them to the BCA gallery which is actually showcase the development of the DFMA and PVVC in Singapore so far. Then the top right photo, we actually also brought them to consultant office to actually hear a presentation by the consultant, QS firm, and a contractor on PVC cost and contractual frameworks. And lastly, the bottom right, we also bring them to one of the site visit of the PVC project, so the tapestry of the Tampines. So the close collaboration between our senior in SISV and HKIS, right, just make me rethink about the purpose of the formation of our ICEC Rising Professional, which also none other than providing platform for the young professional on the knowledge exchange and global communications and the networking opportunity. So that's why we have this ICEC, the RP webinars. So before we move on to the Q&A sections, so I just would like to take this opportunity to do some promotions on our LinkedIn and Facebook profile. So please do follow us on our social media, as you can scan the QR codes and to further keep in touch with everyone from different countries. So locally, if you also would like to contribute or find out more on the young professional activity, please do also reach out to the respective country rep over the ICEC RP committee. So for example, if the HKIS young professional, they actually can look for Sunny. Yeah, for the SISV young professional, actually can look for me or Giselle from the ICEC RP committee. So with that, I will end my sharing and then pass the time back to Lisa.
Thank you, Jacqueline, and thank you, Surveyor Wong, for those insightful and informative presentations. I'm sure our learned audience gain valuable knowledge as to what MIC or PPVC is and how it's currently being practiced in Hong Kong and Singapore. And Jacqueline finally and very nicely elaborated and compared how the practice is in Hong Kong and how the practice is in Singapore. So very well delivered speeches, but thank you very much for Surveyor Wong and Jacqueline. So let us now move on to the Q&A section. We have one question from the audience so far, all the way from Philippines. Salamat. So let me post that. I would like to, so the question, probably Sunny or Jacqueline can take this up as you think fit. So the question is, I would like to ask the acceptability of MIC or PPVC in the industry from Hong Kong and or Singapore, say from the developer side and the contractor side. That is, say 20% of the top developers on high-rise residential buildings and say 30% of the contractors having same capacity to construct conventional high-rise buildings. So I believe the question is, how is the acceptability of MIC or PPVC from the industry? Say, if Surveyor Wong can describe how Hong Kong construction industry, the developers and contractors accepted MIC, and followed by Jacqueline to elaborate how Singapore developers and Singapore contractors accepted this or are accepting this new technology. Surveyor Wong?
Okay. Okay, I guess I can answer for the Hong Kong side. Actually, MIC in Hong Kong is still at the pilot stage, as we just discussed just now. The majority of the project, I would say, is on the public sector side, yeah, including those service quarters and some student residents from universities. The MIC is now currently promoting to other private developers, and is in the beginning stage, I would say, at the beginning stage. For contractor, there are still some around, 10% of the current local contractor who are capable for the MIC contracts.
Jacqueline, how about Singapore case? How do they accept this PPVC in Singapore?
Okay, I think thanks for the question from the Philippines. So I think as I actually shared just now, so how actually Singapore is being embarked in this PVVC journey, right? Actually, it's a government initiative. So they actually has start off to allocate a fund, which is quite a lot, 450 millions, to actually set aside to just want to boost the DFMA, which is including PVVC in Singapore. So I would say that, and also they actually have also set out to be a mandated requirement in the government land sales condition. So I think the government actually really give a lot of support. So they not just like generate demands. They also have, because in Singapore for BCA, we also have a training school, it's called BCA Academy. So they also provide a lot of training courses, even including like specialist diploma on BIM, on construction productivity, on what is DFMA, like not just for the contractor, also for engineer, for architect, how they actually can collaborate with each other for all the PVVC construction process from the beginning, from design, construction, out to maintenance. So the developer, the contractor, and the consultant, in fact, is receiving a lot of support from the government. So in terms of the acceptance, whether how effective the industry player is, I would say because there's a strong support from the government, is kind of like a lot of contractor actually is like fighting to actually want to be registered. If not, they actually will actually lose this the new game that actually happened in Singapore. Yeah.
Thank you, Wong and Jacqueline. We have another question from all the way from Nigeria. The question is, if there are construction cost reductions in the MIC or PPVC variants. So I believe our participant would like to know how the cost will reduce. I think in Surveyor Wong's presentation, he said there are some reductions due to usage of PPVC. So if you could kindly elaborate what are the savings which we can get due to the adoption of MIC?
I guess, Jacqueline, can we just move back to the comparison table about the reduction cost? Yeah. Yep, one more. Yeah. From let's say, actually Hong Kong, there's not many of the completed project who can let us have the analysis of the cost. But in general, I mean, during the tender stage, it was generally reduced by about 10% of the construction cost. But if you ask what is component who compose this 10% that need further analyzed? Yeah. Maybe Jacqueline, can you share about Singapore?
Okay, maybe let me just flash to the cost driver slide that I shared just now. Okay, so I believe the cost driver that constitute to the cost premium in Singapore is quite similar to Hong Kong as well, because we are actually quite similar item. So I would say that because I think in the beginning there's 18% as we just implemented in 2015, and in fact when I was actually having a PV project previously in my previous company. So at that time when we do the cost estimate for the PVC cost as compared to the conventional method, we also estimate the cost premium to be 10 to 15% back then. But now, according to the latest study actually conducted by BCA, it's actually further dropped to 8% as of last year. So I would say that as you can see from the 6 component over here, one of the things that actually can so-called maybe in future can be further reduced down, maybe is the precast mold. So the precast mold, as what I understand, one mold itself actually can out to 5-digit Sing dollar, just the mold itself. So let's say if this building total PVC module maybe have 1,000, then let's say they need 200, 300 mold. So you can see how the cost actually can it be. So it actually depends on, but for another designer, they also the similar 1,000 module, they actually can design the precast mold, which means the reusable of the module can be maybe dropped to hundreds or 150. So this actually can affect the cost premium for the project from project itself. So one thing that in terms of the precast mold, the cost premium can be reduced is actually out to the capability of the designer, how actually the cooperation between the PVC contractor and the designer, how they actually can design a more effective PVC module. And another thing is for the hoisting crane. So actually just because the mold itself, the PVC module itself actually is quite heavy, as actually mentioned just now, even similar to Hong Kong. So the normal crane actually cannot really lift out the PVC module. So need to be a heavier crane. So when the Singapore actually just started the PVC journey, not many contractors actually dare to invest for this heavier hoisting crane in the market. But as along the way, as you can see, the project number is being increased, and in fact, by right, the targeted PVC module in these 2 years is double than what the existing project. So actually, more contractors have investing and also bringing more hoisting crane to the market. So this actually will lower down the cost of the lifting, which means will lower down the preliminary cost, which the cost premium actually can maybe will be further reduced in the future. Yeah.
Thank you very much, Wong and Jacqueline. We have two more questions which are of similar nature, so I will rephrase that. Ladies and gentlemen, the question is regarding the structural stability of the work when compared to conventional and PPVC or MIC modules. So the questions are how are the structural stability ensured in PPVC models, whereas in conventional in-situ construction, the structural stability is well known and tested before. But how do you ensure the same structural stability in PPVC modules or MIC modules or buildings? Can we elaborate something on that?
I mean, thank you for your question first. Yeah, but do we have such information about it? I doubt that. I doubt that about the structure stability. Yeah, I actually don't have any information in hand with me. Yeah, about the structural part or the stability part of the MIC project that's ongoing.
Yeah, I think it's the question could be more relevant to a structural engineer and construction professional. So I'm sorry, ladies and gentlemen, there were two questions on the same topic. So we as cost engineers and QSs may not be the ideal persons to advise on the structural stability. So
but maybe
sorry
just
about that.
yeah, so because we are actually cost engineer and QS, so maybe just in a general, because I visited the PVC site before together with the structural engineer and the archi. So I think during the presentation and the visit, actually the engineer also asked a lot of questions to the PVC contractor, how actually you design. So that's why actually I flashed this side. So you can see for the left hand side, the PVC module. So most likely this will be built next to the other one. So how this, the adjacent, the wall, how they actually can connect to each other. So how actually make it that, because the conventional way is we actually just build everything. Sorry, I think there's a noise from someone. Okay. So actually how to ensure that when all the PVC module actually being connected to each other, the structure, maybe how to put it, the structure score or the stability actually still to be ensured. So what I understand is when they actually put the module side by side, they will have some grouting and also will have some pre-design the reinforcement bar to put in between. Then after that, they will put the grouting or maybe put concrete or screeding. So just to make sure the two modules actually stick to each other. So yeah, maybe this is one way that to ensure the structure or stability. But I quite pretty sure that they definitely had looked into how to make this stable. That's why the Singapore government actually is now full force to pushing this to all the residential and the hotel project. Yeah.
Okay, couple last two questions. The next question is that's from Sri Lanka. Have you identified any alternative materials, especially lightweight materials, other than concrete and steel in MIC or PPVC? In some of the projects you have visited and where you showed the case studies, have you seen other than concrete and steel any other form of lightweight materials used, Jacqueline, Sunny?
I have actually heard of aluminium, from some factories in China, but I don't see that was implemented in Hong Kong. I mean, for aluminium,
Same with Singapore, Jacqueline?
Actually not that I heard of alternative material. So it's still mainly on concrete and steel.
Okay, great. So last question, I think this is a good question to wrap up the session as well. So just in summary, if Sunny and Jacqueline can explain, the question is, what are the advantages of PPVC or MIC over conventional methods? So if you can elaborate why we should use PPVC as opposed to conventional method, and how do you think this will go into the future? That will, I think, wrap up the session quite well. Sunny, you are on mute.
Yeah, okay. Okay, actually, if you look at the PowerPoint slide here, it states the claimed advantage of MIC or PPVC, including improving the productivity in terms of time, maybe, cost, maybe, yeah. And second one is reduce the on-site labor, which also lead to a more safer working environment. The third one is improving work environment, which also lead to the reduction of some pollution or some wastage. Yeah. And last but not least is the quality of work, because the modules are constructed or manufactured in a controlled area.
Anything to add, Jacqueline, as a final note?
Yeah, maybe I just
about
to,
benefits of PPVC?
yeah, okay. Yeah, just to add on, I think the advantage is similar. So maybe I just to add on, as you can see how actually Hong Kong and Singapore embark on this modular construction journey is actually backed up by the government. So I actually would feel that how this PVC or MIC can be successful, the government support is very, very important. And yeah, so on top of all this advantage, I think the key point is the government initiative. Yeah, thanks.
Thank you, Wong and Jacqueline. So, ladies and gentlemen, we have come to the end of a very thought-provoking and informative evening. And we highly appreciate the active participation of our learned audience. And we hope that you will continue supporting ICEC Rising Professionals and continue to join our future programs as well. So, I am quite sure you have learned a lot about MIC or PPVC tonight, and this will be very valuable in practicing and being future stars in the construction world. So with that, one final note, if you would like to contribute as a speaker, we would kindly request you to send your profile and topic to ICEC Rising Professional 2018 at gmail.com, the email address. I have mentioned it in the chat as well. So if any of experts are here who would like to contribute and disseminate your knowledge, we are ready to put a platform for you to reach other professionals in other countries and to hear you. So please feel free to forward your profiles and topics to this email address. So with that, ladies and gentlemen, let us conclude this wonderful evening. Once again, thank you very much, Surveyor Sunny Wong and Jacqueline Huan, who contributed immensely to this presentation. And lastly, but not the least, a very big thank you to the lovely audience we had. So thank you and good night. Have a safe journey. Bye-bye.